We now turn our attention to incidence rate, which is now a rate. And so if you want to get a rate, this is a suitable way to do it. In the second video, I'm first of all going to just talk very briefly about what we mean by risk, because we use the concept when we speak about incidence rates. And then we'll speak about the incidence rate and show how to calculate it before sharing some examples. We're also going to learn that there's a relationship or a formula that links prevalence, incidence rate, and the duration of the disease. That's the third variable that links them together. We're also, from time to time during this video, going to distinguish between two kinds of incidence rate, the cumulative incidence rate and the incidence density rate. Having dealt with prevalence, we're now ready to start with incidence. However, before I talk about incidence, I'd like to talk about the issue of risk. We say that individuals are at risk for a disease if they don't have the disease at the start of the study period or observation period, and if they're capable of developing the disease. Obviously, men are not at risk for uterus cancer. And also, if it's an infectious disease, they're only at risk if they have not been immunized. Remember, you can become immunized through having received a vaccination, but also it can arise naturally as a result of infection. We're now ready to speak about the incidence rate. The incidence rate is, in epidemiology, we tend to use not just the cases in the numerator, but rather the proportion of a group that has the case in the numerator. So it'll be new cases per 1,000 or new cases per 100,000 per unit of time, rather than just cases per unit of time. So we prefer to use the standardization by the population so that we can actually make meaningful comparisons. This will become obvious in the next few slides as to why we do this. What about the population at risk? What if we don't know what it is? Well, we often then use the mid-year population at risk. It's an estimate of the denominator size. There are two kinds of incidence rate. Cumulative incidence rate, usually used to calculate or estimate risks, where we use the numbers that are disease-free at the beginning of the study period, and then we follow them up to see if they become cases, and we count the number of cases. The incidence density rate, on the other hand, we use the number of newly diseased people per person year of exposure. And so we need to divide by the number of person years at risk rather than the number of people at the beginning of the study period. Here we have incidence of disease in two different provinces. In the first province, there are 40 cases. In the second province, there are 100. At face value, we may think, oh, the people in province B have got a much higher risk. But is this really so? Notice that the populations are very different. Province A, population 1 million, B, 10 million. We need to convert these to rates, incidence rates, in order to compare and decide who has the higher risk. And here we have it. In province A, the incidence rate is 4 per 100,000 per year, whereas in B, it is only 1 per 100,000 per year. So the people in province A have got 4 times the risk of this disease than the people in province B. A warning that comes from this example: always compare incidence rates. Don't just compare the number of cases. This slide just shows the relationship between prevalence and incidence and the duration of the disease. And I give you an example. Let's assume that TB on average is present for 0.8 of a year, because there's time before diagnosis, then there's time while on treatment, and so on. So let's just say on average it's 0.8 of a year. Then if you want to know the incidence and you only know the prevalence, you can work out the incidence by saying, well, it's the prevalence divided by 0.8, and that will give you the incidence rate. On the other hand, if you want to work the other way, here we've worked it out. Prevalence equals 100 times 500 times 0.8 over 100,000, and it comes to 0.4%. So there's a nice relationship between incidence and prevalence. Just a final point that we've alluded to already, but I need to re-emphasize it. What happens if a person gets a disease more than once during a given observation period? Well, if you're working with the cumulative incidence rate, you only count the initial case, and the number at risk is used as the denominator. So it's a number of people in the denominator. If you're doing incidence density rates, on the other hand, you count each and every episode. And the denominator now is the person years at risk rather than the number of people who were at risk at the start of the study period. This is an important, subtle distinction between the two, and it helps us to decide what to do with repeated cases.